This video is for lesson 30-3, area of rhombuses and trapezoids. Learning goals are to solve problems involving area of rhombuses and trapezoids, and to solve problems involving density. Here is a picture of a rhombus. A rhombus is a parallelogram with 4 congruent sides. Because a rhombus is a parallelogram, you could find its area using the formula for parallelogram. Or you could find the area of a rhombus using a formula specifically for the rhombus. That formula involves the lengths of the diagonals, and it is that the area of a rhombus is equal to 1/2 times the length of one diagonal times the length of the other diagonal. I'm using the letter D to be the diagonal. D1 means one diagonal, D2 means the other diagonal. Please add this formula to your note page along with your other area formulas. In this lesson, let's also discuss how to find the area of a trapezoid. Let's create another formula for our notes. Area of a trapezoid is equal to 1/2 times the height of the trapezoid times the sum of the bases. Let's use the letters B1 and B2 to represent the bases. Please add this formula to your notes with your other area formulas. Let's go to number 4 and try some examples. Find the area of the trapezoids. To find the area of a trapezoid, we're going to use the formula area equals 1/2 times the height times B1 plus B2. In this problem, this is 1/2 times 4 times B1, which is 2, plus B2. But we don't know the length of B2. We don't know the longer of the two bases. We need to find that. Notice that the height is drawn with the dashed line, and that creates a right triangle. The unknown side of the right triangle we could call A. The 4 is the B, and the 5 is the C in the Pythagorean theorem. Over here where there's some space, we could show the Pythagorean theorem. A squared plus 4 squared equals 5 squared. Therefore, A equals 9. 5 squared is 25, 4 squared is 16, 25 minus 16 is 9. Taking the square root, we get A is 3. Where the letter A is 3. That means that if we were to do the same thing over here and make another right triangle, this corresponding distance would be 3. How long is it from here across to here? That's 2, the same as it is up on the top. So how long is the entire base of the trapezoid? It's 8. We were able to find B2 by using right triangles and the Pythagorean theorem. Now we can get the area of the trapezoid. 1/2 times 4 is 2, and 2 times 10 is 20 square feet. Now question B. This is also a trapezoid, but it's tipped up on end. The parallel sides are actually going up and down in this drawing, but they're still called bases. So the shorter of the bases is the B1. The longer of the bases is the B2. The height of the trapezoid is the line that connects the bases and touches them at 90-degree angle boxes. This can be confusing because we're used to height meaning up and down. But this trapezoid is tipped up on its end. The height of the trapezoid is the distance between the bases. We could call that h for height. To find that, we could draw right across here. Do you see the right triangle that's created? This right triangle is a special kind of triangle called a 45-degree, 45-degree, 90-degree triangle. The entire length of this side is 9 feet. But just this part is 4 feet, and so this here is 5 feet. If one side of that triangle is 5 feet, so is the other side. We're able to use what we know about 45, 45, 90-degree triangles to find the height of our trapezoid. It's 5 feet. Now we can get the area. 1/2 times the height times B1 plus B2. This answer is 32.5 square feet. Remember, in this lesson, we've been using the real-life scenario of a company that creates tabletops, and they've been calculating the cost of those tabletops based on the area of the tabletop. Now let's consider the cost of shipping for the company. The cost to ship an item often depends upon the mass of the item, how much it weighs. Mass of an item depends upon the density of the material used to construct the item. For example, if you were to make a table out of lead, that would be very dense compared to making a table out of plastic. A table made out of lead that is the same size as one made out of plastic would be much more dense. It would have a lot more mass for the same sized table, and that would cost a lot more money to ship it. Let's work on problem 5. A cut above, that was the name of the company, is making a tabletop shown in item 4A. They make the tabletop out of western red cedar and another table out of maple. The volume of each tabletop is 4 cubic feet. The density of the western red cedar is 23 pounds per cubic foot. But maple is heavier. The density of maple is 45 pounds per cubic foot. If the cost of shipping is 50 cents per pound, which tabletop costs more to ship? Does it make sense that it would be the table that's heavier? That's going to be the table made out of maple, because maple was more dense. It weighed more per square foot. How much more will it cost? To find this answer, let's figure out each cost, subtract them, and we'll know the answer. First, let's work with the cedar, which was the lighter of the two woods. It's 23 pounds per cubic foot, and the table has 4 cubic feet of volume. So 23 times 4 is 92 pounds. That table weighs 92 pounds. It costs 50 cents per pound to ship it. So let's multiply by 0.50. We find out that it is $46 to ship the cedar table. Now let's work with the maple table. Maple is a heavier wood. The density of maple is 45 pounds per cubic feet. And the table is 4 cubic feet. So 45 times 4 is 180 pounds. Let's multiply by 50 cents per pound. And that is $90. So it's $90 to ship the maple table, $46 to ship the cedar table. We can use subtraction to find how much more it costs. The answer is $44 more. So we discussed density, but the most important idea in this lesson was finding the area for a rhombus and a trapezoid. Let's try one more example of each. Right here where there's some open space, let's create a problem involving a rhombus. So I'm going to draw a 4-sided shape where all sides are equal. Next, I'm going to draw the diagonals. Here's the long diagonal, and then here's the shorter diagonal. The diagonals of a rhombus are perpendicular. Let's make believe that this is 6, this is 6, this is 3, and this is 3. And we want to find the area of that rhombus. We use the formula, area equals 1/2 times d1 times d2. This is 1/2 times 12 times 6. The answer is 36 square units. Let's do one more example involving a trapezoid. Here is a trapezoid. Let's say that this side is 4, that this side is 7, and that this side is 5. If we want to find the area of the trapezoid, we use the formula. A equals 1/2 times h times b1 plus b2. This is 1/2 times 5 times 4 plus 7. And this answer is 27.5 square units. So in this lesson, we found area of a rhombus by using the formula involving the diagonals of the rhombus. Or, because a rhombus is a parallelogram, you could use the formula for a parallelogram. We also found the area of a trapezoid using this formula. Both of these formulas need to be in your notes.